everyone, welcome to terminate. In our previous video, we learned how our current number system was developed. The invention of the Arabic number system led to the smooth running of trade among nations worldwide. It did not end there. They moved on to categorize numbers to make them easier to work with. So in this video, we will learn about the types of numbers. Our Arabic number system has two main groups, the real numbers and the non-real numbers. The real numbers include A, natural numbers, denoted by the capital letter N. These are counting numbers starting from 1. That is, we have our 1, and then your 2, your 3, your 4, your 5, and so forth. These numbers are called natural numbers because we count. When we count, we naturally start from 1. We use natural numbers when counting items. For example, when counting money, pencils, sweets, etc. We start counting from 1. The next group of real numbers, real numbers, are whole numbers, denoted by the capital letter N and a small 0. These are counting numbers including 0. So when we start by counting 0, 1, 2, 3, 4, 5, and so forth, then they are whole numbers. These whole numbers are essential for measuring instruments, as you know that all of them are numbered from 0, like the tape measure is starting from 0 until, like for instance, this tape measure is from 0 to 5 meters. And then the scale always starts from 0 up to maybe 100 kgs or 100 grams or 1000 kgs. And the measuring jar, measuring jar also starting from 0, our ruler starting from 0 to 30, 0 centimeters to 30 centimeters. And then our protractor, which we use in our maths protractor, is starting from this side, going this way. It will start from 0 to 180 degrees. And if you are measuring from this side to that side, it will be from 0 degrees to 180 degrees. So we move on to the third group of real numbers, which are integers. These are all the positive and the negative whole numbers on a number line. That is 3, 8, minus 4, minus 15, minus 17, as long as the number is a whole number. So we have positive integers, which are denoted by the capital letter Z and a plus sign. And these are all the positive whole numbers. That is the 0, 1, 2, 3, 4, and so forth. And the negative integers denoted by the capital letter Z with a negative sign at the top. And these are all negative whole numbers. Minus 1, minus 2, minus 3, minus 4, minus 5, and the list goes on. And all these can be shown on a number line. Say this is our 0. It means going to our right, these are positive integers. And going to our left, these are negative integers. So they can all be shown on the number line. The list going to your left is endless. Can go to minus 1,000, minus 10 billion, as long as they can fit on a number line. Right? The fourth group of real numbers are rational numbers denoted by the capital letter Q. Rational numbers are all the numbers that can be represented as a fraction. And the fraction must terminate. For example, a quarter. If you punch a quarter on your calculator, you will find out that it will give you 0.25. So 1 divided by 4, your answer will be 0.25. Okay. Same with 3/5. Changing it to a decimal fraction, it will give you 0.6. So these decimal fractions are terminating. So the decimal fraction on 0.25 ends at 5. And then the decimal fraction for 0.6 ends at 6. So we call this terminating. So a decimal number or a fraction becomes a rational number when it ends. And then it also going to be a rational number when it recurs. For example, 2/3, if you punch 2/3 on your calculator, you will find that is 0.666666666, and the number will goes on. It does not terminate. It will continue recurring, which means the 6 here with the dot at the top continues to recur. Right? The last group of real numbers are irrational numbers, denoted by the capital letter Q and the complement at the top. These are fractions that do not terminate. For example, the pi does not terminate. And these fractions do not recur, like the root 2. The 4, 1, 4, 2, 1, 3 is not like in the case of 2/3. The 6 is repeating itself until I don't know. So irrational numbers do not terminate and they do not recur. And then the last group of numbers is the non-real numbers. These are all the numbers that do not exist in our everyday life. For example, the square root of all negative numbers, including this I. You see, this I is the symbol for minus root 1. So the I is a non-real number, or it's a complex number to deal with, but we'll use it as you progress with your maths course. So these non-real numbers cannot be represented on the number line. Right. So the real numbers and the non-real numbers are the two major groups of numbers. So let's move on to consolidate what we have learned so far. The instruction goes, tick the set or sets in which the given number belongs. Like if we take 0, divided by 5, we cannot tell what this fraction is until we punch it on the calculator. We can cancel this one. Then we have 0 divided by 5. Our answer is 0. So we automatically know that 0 divided by 5 will give us the answer 0. So we now consider 0. Is it a natural number? Yes, it's not a natural number. We can't, because natural numbers start from 1. Is it a whole number? Yes, it's a whole number because all instruments are numbered from 0. Is it an integer? Yes, it's an integer. Is it a rational number? Yes, it's a rational number and also a real number. So 0 belong to all these 4 types of groups. Now we go to root 9. We know the square root of 9 is 3. So we use 3 to categorize root 9. So is it a natural number? Yes, it's included because natural numbers start from 1. And whole number? Yes, it's included because whole numbers start from 0. Is it an integer? Yes, it's a positive integer. Is it a rational number? Yes, because we can say is 3 over 1 becomes a fraction. So it's a rational number, but it's not an irrational number. Now it belongs to the overall group of real numbers. Right. Minus 6 over 3, it means minus 6 divided by 3, whereby our answer is minus 2. So we deal with minus 2 to find out in which group does minus 6 divided by 3 belong. So minus 2, is it a natural number? No, because natural numbers start from 1. Is it a whole number? No, because whole numbers start from 0. Is it an integer? Yes, because they are positive and negative integers, and it's a rational number and also belong to this group of real numbers. Right, you will go on. If we go on to minus root 9 divided minus 2, it's like the negatives will cancel each other to give us a positive. So root 9, as we know, is 3 over 2, which will give us 1,5. So this fraction is terminating. Is it not a natural number? It's not a natural, it's not a natural number because natural numbers are whole numbers from 1, and it's not a whole number, and it's not an integer because integers are positive and negative whole numbers. Is it a rational number? Yes, because the decimal terminate or ends. It's not an irrational but belongs to the group of real numbers. So minus root 9 over minus 2 belong to rational as well as real. Right. If we punch, we can't tell to which group cube root of 7 belong unless we use our calculator here. So we'll punch 7 and then second function and then the cube root will be that answer. So we learned that irrational numbers are those that do not recur and they do not terminate. So this number 1,91293 is not recurring, is not ending. It will continue to go. So we actually know that the cube root of 7 is irrational, and it also belongs here. It's not rational, it's not integer, it's not whole number, it's not natural number. And also the pi, you must go to your calculator and punch pi to find out what kind of decimal fraction it will give you. So after punching pi is 3,1415. It's not recurring, it's not ending. So same as the cube root of 7. So pi is an irrational number as well as a real number. So in our everyday lives, we will find out that if you are using an instrument, you are using whole numbers. If you are counting to find out how many items you have, you use natural numbers. So in our everyday lives, we use that group of numbers called real numbers. Thank you so much. Bye-bye.